what you have here?
Sure. We work with we're an interdisciplinary group. We work out of the Beckman Institute in the Coordinated Science Lab, and we work with the railroad program. What we're trying to do is replace the human inspection with cameras and computers.
Okay, so this inspects the railroad track.
Right.
Can you explain how that works?
So we roll it down the track. This actually rides on the track. We got borrowed this from the Monticello Railroad Museum.
Oh, okay.
And we put a battery and a motor on it, and also to run the cameras and laptop. As it moves down the track, it records a video of the rail, and we inspect the components that are on there.
Okay, so it can detect. What is it looking for? Like missing pieces
So
or
it looks
broken
for
parts?
raised spikes, which I'm sure you've probably seen on the track.
Oh, just like that.
Right. One
Okay.
isn't a problem, but if there's a series of them, that means
Yeah.
the track is becoming loose. We also look at the anchors that are on the sides, and that stops the rail from shifting back and forth.
So does somebody come back and like review the footage and like?
Oh, well, we
At a
do all
computer?
that. We'll do all that with computer vision automatically.
Oh, so it can automatically detect problems.
Yeah, it finds the tie plate and then looks for the spikes and the anchors, makes sure that they're there and properly installed, and also that they're not missing and that the pattern is correct.
So if there's a problem, it'll like tell you where it's at, and you can go and fix it.
Right. It marks in the video where the problems are, what it finds, and where the problems are.
Okay.
And then eventually we would have this on a high rail vehicle that rides the track and would help the inspector find the problems automatically.
That's great. What else do you have here?
Most is just about how the computer vision algorithm works. It's
Oh.
based on texture.
Okay.
So the texture of rail is much different than the texture of the stone and the wood texture. So we can identify the components that way and localize the tie plate here in the center, which is where the main components we're looking for are. Because it's very hard to find the spike head because it's the same color as the
Yeah.
background.
Yeah.
If we localize this area, we can better find those spikes in the holes where they're supposed to be and find out if the spiking pattern is correct.
Okay. That's great. Is there anything else you want to show us, or is that about it?
Well, we've got several other
Oh,
projects.
Okay, sure.
This one here looks at how intermodal containers are loaded onto a train. Basically, we look at the aerodynamic efficiency of how well it's loaded. So if you leave a container off, the wind blows and into that area and pushes on the train. It slows the train down, and it needs to expend more fuel to keep up speed. So what we do is we set up a camera on the side of the track and take a video of the train going by. We extract the background from each image. We take a small section from each image in the video, put those all together into a panoramic image of the entire train, which you see in this poster here. Then what we do is we look and measure, we identify the types of loads that were on there, and also we measure the gaps in between. The smaller the gap, the less air that can get in there.
Mm-hmm.
So we tell how well we score how well it's loaded.
So what's like the ideal situation?
Basically, we want as small a gap as you can. So
Okay.
a lot of cars can take a larger container on the top, which will decrease the gap size.
Okay.
And we score how each car was loaded, and also we give a score for the aerodynamic coefficient of the whole entire train.
That's neat.
We have a site in Kansas City, Missouri, where all this is done automatically. Inside this bungalow, we have computer equipment. Takes the videos. This is a camera on a tower here. Takes the videos and runs our programs automatically and generates reports on the scores of the trains that pass by.
Okay. That's very interesting.
Thanks.
All right. Thank you very much.
All right.